Hello everyone, good morning, good evening, whenever you are in the world, welcome to my channel. If you are here to learn about the trust analysis, you are in the right place because in today's video, we will be tackling another example problem and this time focusing on determining trust member forces using the method of section. So let's dive into the problem, and here it is. Determine the force in member GE, GC, and BC of the bridge truss shown in figure below. Indicate whether the member is in tension or compression. So this is our elevation of the truss, and we have given 400 newtons applied to the right, and we have a 1200 newtons downward here. The truss is pinned at one end and roller at the other end. The height of the truss is 3 meters. We have an equal 3B at 4 meters on center. So this is the pre-body diagram of the truss. We have the horizontal reactions of support A and vertical reaction, and we have the vertical reaction at support D. So here in method of sections, we will cut a line here, these three members, where we have three unknowns, GE, GC, and BC. Take note, guys, that when you cut a section, make sure that the maximum of members that we're gonna cut is only 3 members. That is the maximum allowed members to cut. And make sure also that when we cut a members, when we sum up moment at some point, let's see, we sum up moment C or G, so make sure that we will have less member unknown, and we will show that later on. So here in our solution, determine reaction load. So to determine the reaction load, we have the pre-body diagram here. So we will sum up forces along x-axis, which means we have the horizontal force applied here to the right. So we have also the reaction at ax. So summing up moment along x is we have 400 newtons minus the ax, which is to the left because our assumption is positive to the right, is equal to 0. So the AX is equal to 400 newtons. Then the next one is sum up moment A, or we can also sum up moment T, but we have here a summation of moment at A. So 1200 newtons, that is positive clockwise. So the 1200 newtons is clockwise with respect to point A, clockwise. Then times the moment arm, 8 meters, plus 400 newtons, this one here, times the perpendicular distance, 3 meters, that is the moment arm. So minus dy times 12 dy times 12, 8 plus 4, from here to there, so it's equal to 0. dy is equal to 900 newtons from this equation. Then we determine the vertical reaction dy. The next one is we will sum up moment along y. Positive summation of forces along y is equal to 0. So the purpose of summing up moment along y is to determine the reaction AY here. So AY minus 1200, which is this one, negative because it's downward, plus 900, which is dy, this one, is equal to 0. And the answer is 300 Newton for AY reaction. So we have already determined all the reaction. Then we will proceed to determine the internal forces of the unknown members. So here, determining member forces, GE, GC, and BC. So this one, guys, is this is the cutting section here. If we separate this section to the left, this is the one here. So we have the internal forces, GE, and this one here, GC and BC. So these are the internal forces, axial load of the members. Then we have the reaction here. That's why we calculate the reaction first, because we need that reaction to be known. So the next one is if we sum up moment at G, we will have this unknown FBC. Then we have the vertical reaction 300. So we have 300 Newton. So we have only one unknown if we take moment at G. So 300 times 4, moment arm, plus 400 times 3, which is this one here, times 3, the perpendicular distance, minus force BC, which is this one, times the distance 3 meters. This one is equal to 0. So solving force BC is equal to 800 Newton. This is in tension. So that is in tension. But if we come up negative value, which means this one is opposite direction, which is compression. But here, positive, that is tension. Then the next one, we will sum up moment at point C. The purpose of summing up moment at point C is to determine the unknown GE, force GE. So we have here 300 times 8, 300 times 8, this is the moment arm, plus FGE times 3 meters, this one, is equal to 0. So force GE is equal to 800 newtons. And that is compression. So which means GE is compression. It is positive as unknown, which means the assumption of the direction of forces is correct. Then the next one is to determine the force GC, which is this one here. So to determine forces GC, we can determine this by summing forces along Y. If we sum up forces along Y, we have only one unknown. You see here, only FGC, only the unknown, and we have the 300 reaction vertical. So we have 300 positive minus the vertical component of forces GC. The vertical component of forces GC is 3/5. You see here, 3/5, then is equal to 0. So FGC is 500 Newton. That is tension, as assumed in the pre-body diagram. So we have calculated the required axial force of the truss member. So the next one is, I will leave you this to you guys to solve this one as part of your exercise. And once you solve this one, please comment down below with your answer so that I can compare it also with my answer. So thank you guys, and if you find this video helpful and if you learn something with this video, please don't forget to like or subscribe, and that is free. So thank you for watching. See you next time. Bye bye.